Working?
Mics are working. We can start.
Cool.
Yes. All right.
Yeah.
Nice. Welcome.
Hey guys, this is Mallikarjun here. I work as a solution consultant at Sahaj. So I'll just give a brief introduction before we start the talk. So brief introduction about Sahaj. Sahaj is a technology firm founded in 2014. We deliver value to our customers by leveraging our software, data, ML, AI capabilities. DevDay is an informal event that we have kind of organized to bring the tech community together and to share our learnings with the wider community and foster the tech community in general. We've been doing this across different offices. We've recently started this event in the UK. This is our second event. So Akshay and Carmen will talk about data contracts and how you can use them in production. At the end of the talk, we'll share a QR code. Feel free to share any feedback that you have. Over to you guys.
Okay, thank you. So there are two talks actually this evening, both on the topics of data contracts, and both hopefully you'll find them very interesting and kind of full of practical takeaway tips. So the first one is on what are data contracts and kind of how they relate to building successful data products. So before we start, we probably need to give you a bit of an insight into the project that has been such a fertile ground for us to learn about data engineering. Many of the lessons we talk about this evening are really lessons from the trenches. We've learned them the hard way often. So without further ado, kind of this is the project. So for the last couple of years, we've been working with a large publishing company in the UK to help them build up a harmonized view of their journal portfolio for the purposes of driving business performance and measuring and driving business performance. So when we came along, what we saw on the ground was a very kind of fragmented data landscape. So this business has many important sources of data that are critical to the business, but the availability was rather patchy. Much of the data was either only partially accessible or incomplete. So we saw really a wide spectrum of kind of state of data. On one end, we saw situations where some data was just not available at all in the data warehouse. It wasn't accessible to people to consume and to analyze. At the other end of the spectrum, you had some data that had a well-designated data owner within the business. They applied their own level of curation and interpretation on top of the data. They made it available downstream to consumers. And then we also saw everything in between. So other sources of data were available, but only in their raw form. So this could be either relational data or event level data. But there was very little or no interpretation on because obviously this data had all its internal kind of system data, but there was no level of guidance as to how this should be interpreted. Or what data you needed to answer a specific business question. So it was a little bit of a fragmented piece. The implication for those consuming the data was kind of several-fold. So you could have situations where the same data was used but interpreted differently by different teams. And you can imagine how this could lead to very uncomfortable conversations with senior stakeholders because that number did not match that number, or one analysis produced an insight that was inconsistent to another analysis. Then there was data that was just not measured. So there was a big gap in reports because the data wasn't available. And the old saying, what doesn't get measured doesn't get managed, well, is also true. And there could be guesswork leading to incorrect kind of choices of events being used or interpretations. So all of this kind of really was not, I guess, the best situation. Fast forward to where we are today. So we have identified data producers for all the important systems of data. We work very closely with them to make sure that their offering is very well modeled, is curated, is made available downstream to consumers, is highly available. And the implication for I guess those consuming the data is that there's now a harmonized interface and interpretation for them to kind of tap into, and that there's a team kind of sitting in the middle, and kind of this is kind of made up ourselves as Sahaj, and we kind of facilitate those conversations between data producers and consumers. We kind of peel back layers between what consumers say, oh, I need this, I want this, and then producers say, well, you can have this, but this we can't do, or we can't do today. And we kind of facilitate those conversations and the implementation detail. So this is kind of a very brief overview of the project itself. So now that we've done that, it's time to kind of like zoom back out and kind of talk a little bit about what a data product actually is. So at a very high level, a data product is actually made up of kind of three parts, really. You have your inputs. So these are the data sources that you consume from outside the boundaries of your data product. At the other end, you have your outputs. These are the things that you put in the hands of your consumers. It can be a set of tables in a data warehouse. It can be an event stream if you work with that kind of like level of data. It can be a dashboard. It can be a report. It can be anything at all. This is your product that you put in the hands of your consumers. And then you have your internals, which is everything that you do under the hood to convert your input into your output. Now, what's important to call out is that your input can be someone else's data product, and this will be very relevant to the data contract conversation. And then your output, in turn, can be someone else's data sources acting as inputs into their products, which also has a relevance on the data contracts that we are relevant at that end of the spectrum. So with that kind of infrastructure, kind of framework in mind, I'm going to now pass over to Akshay to kick us off on data contracts.
Carmen. And I know we have a very wide set of audience. So if you have any questions before we start talking about like what a data contract is, feel free to ask now, or yeah, we can also take it as we go. So data contracts, we've understood a bit more about data products and how they are organized, and how can you go about building it. We'll dive deeper into it. But then, so data contracts are basically an interface that can help your consumers understand and interpret data that you're providing them, and that can help them use your data products more effectively. And this is basically a contract that you have to negotiate with them. Just like in the world of software engineering, you will have like your APIs or some protocols that you establish to talk to other systems. In the world of data, you have data contracts to basically establish some sort of a formal communication channel with all of your consumers and with your producers as well, as you will see. So before we start talking more about how you can actually build data contracts, let's understand a bit more about why data contracts and how can they help you make data products that are successful. So this is where, so data contracts, it's always good to agree on what the contract is going to be before you start work on any sort of data products that you're building. The reason is you can kind of clarify with the users of your data in which ways are they going to use this data and for what are they wanting to use that data. This will help you clarify requirements and start diving into the details of the ways in which they want to use this data, and also identify the different use cases that they have in mind, and then try to clarify some of those use cases based on the data that you're getting from your different sources. So you had your sources on the left and then your consumers on the right. So you need to figure out if the sources that you're getting can fulfill all your requirements for data. And contracts are a way in which you can mediate some of these conversations and get people together to clarify some of these requirements. The other thing that data contracts can also help you with is establishing very early on some sort of boundaries on who is doing what and who are the right people that need to be involved in getting your data product going. And then once you've started to like establish some sort of a formal contract, then the teams that are involved, they can go and build their data products based on those contracts. So they don't need to worry about like, oh, we all have to use a single tool. They can independently build these data products with the tooling that they are comfortable with. So it kind of gives you this clear boundaries and definitions of these are the particular contracts that you need to adhere to, but you don't need to dictate how they are built. So these are some of the advantages that you can see from data contracts. The other thing that you may want to think about before you start diving deep into data contracts is whether it's relevant for the problem that you're looking at. So briefly, there's two dimensions here to consider. So one is the complexity of data interactions. So this is to deal with like if you have a lot of teams involved and there is a lot of data being exchanged with those teams. So in those cases, so this is like basically the y-axis. So if you have a lot of teams that are exchanging data, you may want to consider data contracts so that you kind of identify which are the bottlenecks and where are you exchanging data the most, so that you can basically get those teams to talk to each other and agree on a contract of sorts. The other thing is how critical is this data that you're providing to your users? If it's something that is very critical and they need to really have accurate or timely data, then you may want to establish contracts with the producers of your data and also with your consumers so that you can make sure that you can adhere to their accuracy or freshness or whatever criteria they have early on. And then if you have like a lot of complex interactions of data and a lot of critical data, then definitely start thinking about like bringing on data contracts early and then pushing everyone to drive towards like thinking about contracts and then building them early on. So let's talk a bit more about what is involved in a data contract. So there's quite a few components involved. So the first thing is, yeah, identifying the system of origin. Whenever you're building data products, your data, it may be that you are producing some data internally as part of your engineering team, but in many cases, your data may originate from a different team or even outside of your organization. So identifying what are the different sources of data, and then trying to add those into your contract will help people to understand when you're building your contract, where is this data coming from, and help your users also identify the lineage of your data and how it flows. The other thing to consider is schema. So when we are talking about data, it always goes with schema, right? You need to know what is the shape of this data, what are the data types. When you're defining any sort of tables or event streams or what that may be, people need to know what exactly is the structure of it and what all can it be used for. So defining a schema is the obvious part. The other thing to think about, and this is where data engineering kind of starts to diverge a bit from software, is thinking about like how frequently is your data updated. So this is not for me personally, who comes from a software engineering background. This was kind of a shift of, oh, I don't need to think about just like providing the data. I also need to think about, is it complete and is it being provided to them in the frequency that they've requested? And that also determines the way in which you would go implementing your data product. So if, for example, someone comes and says that they want all the data that you've produced right away, then you may go for like a streaming approach. Whereas if your users of data are saying that, okay, we only want like weekly updates of our data, you may go for like a batch-based solution. So you need to think about like how people are going to be using your data to think about how you would then go implementing it. So that's why having some of these conversations early on helps. The other things to consider is then the quality metrics. So what are based on the users and how they are going to be using your data, you may want to focus on some sort of quality metrics around the data product. So that may be accuracy, that may be the completeness or the logic that you're using to produce these data contracts. The other things to consider then is also any sort of known limitations. So if you're getting your data from some third parties, they may not provide you all of the data, or if they do, then there may be some caveats. So just knowing these early on will help you then identify in which ways you can use this data. And also it will help your users to say that, okay, if they are trying to use it for a particular use case, it may or may not fit that. And the other thing that we learned is also establishing some sort of governance and access policies. So this is one of the aspects that gets ignored until very late. As soon as you start thinking of building a data product, think about what are the fields that are going to be sensitive. If there is any sort of compliance or regulatory requirements, you want to think about that early on so that you don't expose any sort of sensitive data to your users that is not encrypted or not meant to be used. So these are some of the components of data contracts. And then what were our lessons? So we helped this publishing organization use data contracts and build data products for them. So I'm just going to share a bit more about what are the kind of lessons we learned as we built them. So the very first thing was when we started working with this publishing organization, the way the teams were structured, they had a lot of different producers of this data. So there were like 4 big sources of data, but then there were n number of teams who were trying to interpret and use these 4 sources. So, and the way that they worked was the people who wanted to use these sources, they would just send the people who were producing this data a spreadsheet with a bunch of columns, and then this team would provide it to them. But there was no kind of common understanding of, okay, you're providing me this data, how are you going to use it? How frequently do you want it? None of this happened. And they also didn't talk about how would you interpret this data. So if they were providing a submission, so this was a publishing company that had a bunch of journals and peer reviews where authors submitted something and they created this submission entity. But this was called a manuscript in some other system. So they couldn't even understand the same language. So what we did is we kind of got them together. So we got all the people who wanted to use this journal data and all the people who were producing this data to sit together and kind of agree on a common language. And that basically meant that we helped them break down the silo that they had between the producers and consumers. So just like with DevOps, where you had the developers and operations people work together, with data contracts, you can kind of start to break down the silo between your consumers of data and the producers of data. And then hopefully they start speaking the same language. And then in turn, that kind of generates some trust because the consumers of your data now understand in what ways they can use this data and what are the known limitations or when is it not applicable to use a particular source. So it kind of establishes this trust between the producers and consumers. The other thing we noticed as part of implementing data contracts is it brings about like a lot of product thinking that is there from the software engineering or like, agile practices into the data world. So thinking about like putting your users first or focusing more on the outcomes as opposed to just output. So like I said earlier, instead of just like, okay, here is like a table with all the columns you requested, you actually have to think about in what ways are they using your data and is it going to fulfill those requirements. So yes, there is more work that you have to put in, but then the rewards are that people actually trust your outcomes and then you're helping your entire organization like move in the direction that they're trying to like go. And then finally, what one of the outcomes of all of this data contracts exercise was that we kind of had this living document that people could just go to understand a data product, what it is, what are the different components that we spoke of. We kind of documented everything in that document. So we just started with a simple spreadsheet. We wrote down, okay, who are the users of this data? What can they do? What are the known limitations, the schema, and all of that. We kind of documented that as we went through this process. And that became a living document that people who wanted to use our data could just go to and refer to. So it kind of became like a data dictionary or a data contract as a living document of sorts. Yeah.
So how reproducible this is across projects. For example, you create one document, you might have some terminologies or some steps around it, like okay, this is all the data and then this is how let's say the consumer will be how projects or like will it require considerable change in the document, let's say?
So you can reuse quite a lot of it once you identify what are the main components that you want to track, right? So we spoke about like the schemas, the known limitations, some of the components. So those are the ones that you can capture in that document. So as long as at a high level you have like, okay, these are my data quality metrics. These are the users, boundaries, known limitations. They are completely transferable across not just between teams, but across orgs as well most of the time.
Also, did you like consider, because I mean, from like usually data, I mean, from a data, like let's say being a producer of I see only two things. The data is being streamed continuously, or it's being in batch, or it's like a dump, you know, not gonna change. These three things that I see. So this document like considers those things that okay, time on those things.
Yes, but that's what. So I think as a data engineer, we need to change our mindset to just say like, okay, you're not just producing a stream or a table. You are actually producing something that is then used by someone else for something that they're doing, right? So they may be building a machine learning model, or they may be building a report for the execs. So depending on what they are using, they'll interpret the data that you've provided in a certain way. So understanding how they are going to use this and then trying to backtrack that into your data product is where the contract helps. So you can provide them, okay, this is a stream that can help you with X, Y, Z, but they need to know what that X, Y, Z is. So for example, we provided them with like a bunch of submissions across their entire portfolio. But then
my question there was, okay, I mean, you have teams here in so this document might be a source of let's say contract for them that okay, this is how it needs to be.
Yeah.
For example, if you're building a data product, don't go about like researching and doing your own research. Like this is a document, this is a format, and of course, research this document has to be the base.
Correct.
You have to build it this way.
Yeah.
I mean, just like let's say, let's take it. There's already a thing that okay, you can't go on building website new. No, request like okay, you have limited set of posts. Posts.
Yeah.
Is it similar?
Yeah, exactly. So it's similar. So using the components of the data contract is what you can then use to plug in different data products. But you need to think about that when you're building your tables or streams or whatever that is. You need to think about all the different use cases that people will be using it for, and then document those. And then, yeah, you can use that template across the organization. So you just need to think about the components that are involved, and you can reuse it. Hopefully
And
that
just to say, like,
clarifies.
oh yes, please.
I have another question. It's not very similar, but one.
I was going to say, like you say, as a data engineer, you only see that the data is continuously being streamed. That's not really a sufficient promise that you can make to someone downstream. I'm just going to give you continuous data. Because they're going to want to do something more specific with that data. So your promise needs to kind of be more nuanced and specific in terms of, okay, it is continuous with this kind of rate, but the quality kind of components and these are the components that I actually talked about have to be kind of baked into that.
Yeah, who owns this document and who needs to read this document? Like in the organization, who owns the document? And which teams needs to agree this document? You know, like basically, yeah.
Yeah. So I'm sure we may have different opinions, but I'll tell you mine first. So in my opinion, whoever is the producer of the data produces this document, but it has to be, it's a contract. So it can't be just one party. So it's a contract between two parties at least. So it has to be the producer that produces the document, but then making sure that it stays updated, making sure that it's fit for different use cases. It has to be both ways. So if something in the contract, so let's say that you have a column that is supposed to be not null, and then suddenly you have a null value, it is also up to the user of that contract to then say that, oh, you said it should be not null, but we've received a null value. So it kind of goes both ways, but the document should ideally be owned by the producers of that data. I don't know if you...
I actually agree with that.
Okay.
I think it's more of a result of a negotiation, but ultimately the data producer kind of owns the document, because ultimately you can have a situation where the consumer will ask for something and you say, no, we are not going to provide that. But what we are willing to provide is this, and then that gets kind of like reflected in this document.
Is there any like high level kind of like agreement there? Like, you know, for example, under the Department of Finance, I don't want to give my data to X or Y department, you know, let's say HR. And then we try to connect all in like power, you know what I mean? Like we try to do one lake. And then there are some kind of, you know, like
sensitive data.
Sensitive information that who, like how, if I'm in a team and whoever's on the data, how can I just like get this kind of agreement from up, down to actually, you know, kind of like these little bits, like agree with, you know what I mean? Like,
So
you know, I see it as a project manager who kind of like support the project to say like, okay, we actually need this data and it's in this document. Even if you don't want this, is kind of this is the document.
So this is where the last part, the governance, comes into picture, in my opinion. So you need to have someone who can first of all label data. So if your finance team is like producing this data into the data lake, they need to be able to say like, okay, this is the data that's highly sensitive. If it's like salaries or whatever, we don't want it visible to your organization. It may be in the data lake, but even if you try to query it and you don't have the right permissions, you'll just see garbage. So as long as you can say that, okay, these are salary numbers in this particular table and this column, and if only are an HR person, which is where the access and authorization comes into picture, if you try to query your data lake, then you'll see the real values. But if you're not from HR team, you wouldn't be able to see that.
No, it's good to, you know, when you do procurement, it's kind of project manager.
And I guess that's where the intended use cases come in, because you can say we are making this sensitive data available, but only for these intended use cases. Of there's obviously nothing's technically stopping someone else from sharing on the data, but it's no longer the boundaries of your data product kind of like it kind of leaks downstream into how other people use your data. And I guess that's where organizationally you probably end up in the data protection kind of realm, and that's what the DPOs and I guess GDPR policies, more organizational kind of kick in. But ultimately, the contract kind of states these are the intended use cases. We're only making data available for these use cases under these circumstances.
But the important part is you do this when you start. If you have your data lake, everything is there, people are querying your data, and then you try to put security on it, it's too late, because you know you've already let access. So whenever you're like bringing new data into your lake house or warehouse or whatever that is, think about like data contracts in the first case. Is there a predefined structure? I think there are a few templates out there that you can refer to, but it ultimately comes down to the organization. So it may be valuable to create like an org-wide template, but it has to go through a couple of iterations. So what I would suggest is like start with a generic template, build a couple of data products, and then you'll identify what are the relevant fields that you need in the template. What would you say?
Yeah, I
Yeah.
would say so. And I think hopefully this is why we're hopeful that this talk is useful, because these are the components that you should be thinking about when you are putting that template together. Because it's kind of like doing the hard part is thinking about all the different things that should be reflected in the data contract. And then hopefully just putting the document together is kind of just the final piece.
Can I just ask, is it, I mean, I'm trying to think of it as like an SLA for data recovered data as a service data. But I don't see a component of availability of data. Is that included somewhere? Like how long is it going to be available?
Can you repeat?
Oh, yeah. Sorry. So the question was more around SLAs and availability of data. So there's a couple of metrics here. So one of them is the frequency of updates, and then the other is quality metrics. So quality metrics will capture things like retention and how frequently and if it's even complete. So we'll dive a bit deeper as well. So the second talk is going to dive deeper into some of these components. So yeah, we'll speak more about that.
Yeah.
Yeah. Yeah. Cool. Okay, so where was I? So yeah, how do you get started with data contracts? So the very first thing you need to do when you're building any sort of data product is you'll have a bunch of data sources. Don't just like go and select star on it and then start using it. Try to like establish some sort of contract with each of the source, and then also capture that in any sort of tests that you can. So if you have a framework that you can use for testing each of the source, try to establish that contract with each source and then test it. So every time you receive new data, first validate against your contract that you've established with that source. So understanding that, okay, is it matching the schema that have asked for? If there are any constraints on the data, have they been met? And test for those constraints. And only once that met, then you can like choose to use it for your transformations that you have. So you have your transformations there. And then, so the other thing that you can do is then also you'll build your transformations, which is your internal logic, and then you'll be producing data outputs. But then before you do that, you should also ideally, like, how you test your software, you need to test that the outputs are actually meeting your expectations. So similarly, you can use the contracts that you established with your users, your consumers, that they are meeting the contracts. So if they are not, then don't maybe refresh your table because you'll be providing them bad data. So test your outputs and your inputs as well. So start from the outside and then like build yourself in.
When you say this, what? Because I mean, writing tests for data which is like something which is not in the real world. It's easier, but some data which is how do you?
Yeah, and
the second talk is all about that.
Yeah. So yeah, we'll talk more about this, but the gist is test the contract. So that's why we established the contracts in the beginning. Yeah, these are the key takeaways from the first talk. We'll take, I think, a 5-minute break, and we'll start at 7:10. But yeah, if you have any questions, feel free. Yeah.
Right.
Thank you.
Thank you. I'll sort it.
What do I need to do?
Nothing.
I just
I'll
need to
sort
close it?
it. Yeah,
Alright.
this is a different day. All right. So this time we have a microphone that can kind of go around. Just put your hand up, and Vikas is going to pass it around to make sure that the people who are listening on the stream. All right. All right. So in the first talk, we kind of gave an overview of data contracts and how they, well, we believe they're the cornerstone to building successful data products. So in this second talk, we're going to talk about, I guess, the nitty-gritty of implementation, lessons from the trenches. So first, we'll talk about validation. Now, like Akshay mentioned, you probably want to start validating, kind of setting tests from the outside, from the edges kind of coming in. Now, if you only have very limited time, we suggest that you really double down on validating your outputs and setting really rigorous tests to make sure that the promise you are making with the data product continues to be satisfied. That probably won't be enough, but it will be enough to help you catch blind spots and any kind of logic changes upstream. In the ideal case, you also want to set tests at the other edge, the input edge, to make sure that all your inputs, you will probably have carried out a similar exercise in terms of arriving at data contracts with whoever's produced those inputs to make sure that those kind of continuously get satisfied. And you might find that over time, there will be things that you haven't actually thought about testing that you need to continuously add tests. For example, you might not have thought to check for dates that arrive in the future in your initial kind of iteration of your validation, and over time you realize that probably becomes necessary. And then as your data product becomes more complex and matures and becomes more complex, you will find that inside your internals, you will have areas of risk and complexity that warrant more validation to be defined. So your validation suite will evolve as your product evolves, but you want to start at your edges and kind of build your way in. So this is, I guess, the first part of the strategy around actually implementing data contracts. The second one is around, now that you've got your validation, like how do you trace and kind of handle the unexpected data from the edge to edge of your data product? So one thing that we have done very successfully in this project is to label initially unexpected data. So this means, I mean, we use SQL in this project, but I guess the same concept applies using any kind of like programming language or any framework, is to come up with a set of conditions by which you can label whether a record kind of either meets or doesn't meet that kind of particular set of logic, and you label that record as being unexpected. Having the initial test allows you to then add monitoring on top to see how that number kind of evolves. You might expect there to be never any unexpected data, or you might expect some unexpected data, but you want to see the fluctuations of how many you are getting over time. And actually, we'll talk a little bit more about that later on. What we've also found very useful is to hang on to those unexpected records all the way until we arrive at the, I guess, at the outputs where we produce and put in the hands of our consumers, and do the filtering there. This might seem very unintuitive from a software engineering perspective. Like, why would you hold on to kind of bad data? But the number of times we have had people come to us and say, oh, well, I expect to see this in the output that you've given me, and it's not there. Why is it not there? If you've discarded it really early on, it makes it really very difficult and very costly in the feedback loop for the engineering team to figure out why that query has come up and why that data point isn't included. It's very kind of wasteful. Now, granted, this may not necessarily lend itself as an overall general approach when you have billions of data points, but in a situation where the data product is usually consumed by people that use it for specific purposes, especially for the purposes of kind of business interpretation and insight and analysis, that can be very, very useful tool overall. So this is hopefully the kind of the concept on kind of the strategy to label the records and keep holding on to them, or kind of having visibility into them, is definitely a translatable one to many other projects as well. Now, how do you, now that we've kind of set the framework for the high level for the strategy, like the nitty-gritty of how you validate your data contracts, like where do you start? Well, if we take a very simple data model that is very applicable to this business. So this business has many journals. Those journals have many submissions. Some of them are in flight, some of them are published. Some of them are currently in a collection, some of them are not. It's just a very simple data model. So how do you actually set your test, and what are the things that you actually test for? Well, you start with really the fundamentals, your schema. The column names and the data types, are they what you expect? You then kind of proceed to more rigorous, more nuanced elements of the data contract, like your constraints. You know, do you allow for nulls? Do you have just a certain set of accepted values? Do you need to kind of enforce uniqueness and expect uniqueness? Do you expect referential integrity? And some things that are very, very specific to data engineering, or definitely some types of kind of data products that you don't necessarily test for in necessarily software engineering, say absence of data. So for example, you might, in this publishing business, you don't expect any journals without any submission. So you would need to test that at least every journal has at least one submission. And then there's an element of like logical consistency. So for example, if you are given 3 different data sets where a submission is represented in all 3, they might represent different facets of the submission, but they need to be logically consistent with each other, which is something that you need to kind of test for, because data products are rarely made up of one thing. They're a suite of things cohesively that work together, so you need to test for that. Now, one of the 2 areas that really cause us most problems are uniqueness and referential integrity. Those are where we've seen the most common violations, because the systems that we work with either don't define them, or they don't enforce them, or the data arrives at different times from different systems, and that kind of like highlights gaps in the data. But that will depend from project to project. What we would say is that ideally you want to double down on areas where you know that there's a much greater risk of violations occurring, and kind of invest time in setting kind of validation there. Now, ideally, these violations should be handled at source by the data producing team. But people's roadmaps are busy. You know, things just don't get fixed in time. So effectively, you need to get comfortable with unexpected data. You need to plan for it, because it will happen. And if you don't plan for it, your pipelines are just going to really fail. I don't know, does anyone remember the air traffic control fiasco from Bank Holiday Monday last year, when the entire air traffic space in the UK completely shut down because of one flight plan in an unexpected format? And that resulted in tens of thousands of people kind of being stranded and not going on their holiday, myself included. I'm not going to forget that very soon. So it can happen at that scale. It's ridiculous when you talk about it like that, but it can happen. So yes, plan for it, because it will happen. Hopefully with not such big consequences. Now that you've kind of validated your, I guess your data contract, it's now time to validate your interpretation of the data. And this is something very, very different to what we think of as potentially kind of like as, you know, in software engineering. So what do I mean by that? So in this kind of very simple data model, you can have a submission that has an attribute called is currently in collection. You can have a situation where this is actually a matter of interpretation. And what do I mean by that? Well, you can have that field satisfy all your data contracts. Here's a Boolean field. It has no nulls. It's always true or false. But is the interpretation correct? How do you test for that? And what does that actually mean? Well, if you think about it, that value of that attribute could be true under a number of different sets of conditions. And all of those conditions or different conditions can all be, oops, that's jumped up, can be correct in a given business context. It's all very context dependent. So how do you validate that a certain kind of business logic is actually correct? Because that definitely sits outside of kind of the framework of a data contract, as most of us kind of think of. Well, there are different strategies for this, but one is, I guess, is the most straightforward to implement with kind of very low cost to engineering teams, is to validate this initial interpretation with your consumers and then make your code a living document. Like these days, any kind of programming language they use can be made very readable. So you can actually express your set of conditions in a way that you can actually link this snippet to your documentation and your consumers, whether that's other engineering teams or whether that's people who are not very technical but are technical enough to kind of read a bit of code, can get the gist that what they think the interpretation is actually what's implemented in live in production. So this is very low cost, it's very effective, and it's very valuable for the as the product kind of becomes more complex and kind of matures. And what we'd also suggest is that your code also documents the reasoning behind a certain interpretation. Not what the condition is, because everyone can read that, but why. And this is because these kind of comments encapsulate business knowledge that often lives in people's heads. Those people move on. And then other teams or consumers kind of come and kind of, they don't know why something was interpreted in a certain way. So this is also very, very useful. So we have an initial validation of the data contract, initial validation of the interpretation of the data. Now, as your product matures, how do you prevent regression? Because in data engineering, especially with complex pipelines, there's a very, very high risk that a small change somewhere in your internals can produce very unexpected consequences or changes in the output. So we've come up with this mechanism that is very effective at testing both small and large changes. So how does it work? Well, effectively, you take the same input, identical, and you pass them through two versions of your pipeline. Your first pipeline is your main branch. This is what's running in production today. And the second one is your feature branch, where you make one change. But both pipelines produce exactly the same set of outputs that you put in the hands of your consumers. The only difference between them is that somewhere along the internals of your bottom pipeline, there's one change that you're making in the interpretation. And then in this framework, you compare each output, the corresponding parties record by record. And you run really kind of deep difference checks along the pipeline. This kind of where the regression testing comes in. So this allows you to do some really useful things. One is it allows you to rule out that you've not accidentally introduced changes somewhere where you did not intend to. So say in this case, you did not target with your change to make any changes in data set 1. So that should turn green. There should be absolutely no difference there. It also allows you to identify that where you did intend to make changes, there are indeed changes that have happened there. So, and it allows you to isolate those changes and inspect them and have a human assess them whether they are as intended. And if for whatever reason those changes aren't exactly what you would expect, those changes can be traced back exactly back to the model or to the component where you have made your initial change to work out, okay, where has that gone wrong? So this has been it has saved our bacon a number of times, because with all the due diligence of peer reviews and QA, we're all human and kind of mistakes happen. So having a framework that applies, there's so many robust practices in software engineering that can test for this. Something like this for data, it can be a real saver. And with that, I'm going to pass over to Akshay to talk to you about data monitoring.
The mic.
So the question is, what tools do you use for like testing your entire pipeline?
Akshay is literally going to talk to about some of those. You're anticipating the yeah.
Okay, yeah, sure. I'll wait.
So yeah, we'll cover some of this briefly now. But yeah, so talking about validation, right? So we talked about how you test your pipeline, and it's all great, and your test pass, but then you push it to production, and then things are like, oh, suddenly things are broken, because with data, you don't really control all your inputs as well, right? Your inputs might be coming from some third party. So that's where data monitoring comes into picture. You need you definitely need monitoring in addition to just testing your pipeline. So, and that's where like having some sort of a data monitoring pipeline or like having something on top of your validations to keep running each time you run your transformation pipeline will basically help you make sure that your contracts are always being met and you continue to like have trust between the users that you're supplying your data for. And then there's different facets for data monitoring as well. So this is again like there's some things that are different here to software. So for example, the freshness is another thing. Like for me, when I started from a software engineering world, I never had to think about like freshness of data. So this is another thing that it's a facet of your data product. You need to think about whenever you're ingesting data from all your sources, is it actually been updated? And is it fresh? If it's not fresh, then you may choose to not even run your pipeline because it's just going to be running on the same set of data that was being used yesterday. So you might as well like wait until and talk to the people who've supplied you with that source to understand why was that data not updated before you run your pipeline. The other thing is, so yeah, Carmen spoke about schema validation and the tests around it. But these tests do need to run in production as well. So this is not just in CI, because as part of your CI, you may run your pipeline and it all works. But then 10 days down the line, someone may have changed one of your input sources, and that will basically end up breaking your pipeline. So you do need to run your schema validation as part of your monitoring whenever you run your pipeline. This was another thing that was a bit surprising for me from a software engineering perspective. Business logic validation. So some of the examples that Carmen gave of finding unexpected stages and capturing results from those test cases as well. Having monitoring around that can then help you build in some intelligence as well with time. And then the other thing is volume. So you need to know whether the data products that you're building, they are actually complete or not. So because people may be interested in the complete data set, they may be running analyses on the aggregate. So you need to make sure that whatever data you've provided is actually complete. And then there may be cases where people may choose not to use your data if it's not complete. So this is where like you need to go back to your data contract conversation on whether you should even run your pipeline if you know that some of your sources are incomplete or not. So you may choose to update your pipeline knowingly that, okay, we've only gotten like 80% of our usual submissions that we get from a particular source, but then you at least have monitoring on it. So you could tell your consumers saying that, okay, we are aware of this problem in one of these sources, and you can monitor these things. And we'll look at some of these examples as well. And you do need to capture all of this changes over time. The advantage of doing that is you can then start adding some insights and intelligence on top of it. So you could use some examples where like you add some standard deviation checks to see if there's any sudden changes in the volume or in the freshness to capture any gaps that you have in your data. So to then dive into some real world examples. So these are all examples where we've encountered problems with the data products that we were working on. So we've just added some examples here for us to talk more about it in detail. So this is an example where we fired off an alert because one of our sources hadn't been updated. And again, this is a very simple alert that you can just like do check on like when was the last updated time of a particular source, or you may choose to like have some other kind of freshness that you've agreed with your data source or data producers. But the important thing is to then alert on it. And then in this case, we were using Slack. It basically fired off a Slack alert. And this Slack alert is not just visible for our team, but it's also visible for all of our consumers of our data product. And they can look at it, and they can also look at, or there's like 2 people who are working on it. So it kind of builds in like this transparency with your users, and it helps you build trust over time that, okay, whenever something does go wrong, there are people working on it. And if they're interested, they can follow along as well. So this is where you need to like start bringing people on the journey with you. And that will help you have like build more trust with your users. In terms of the tech stack, so in this case, we've used DBT, Airflow, and something called Redata. So these are basically like open source tools that are out there that you can use for like transformations, orchestration, and monitoring. So it's like some of the tools that we use. There's many other options out there, and your choices may depend based on what tooling that you're comfortable with, or even like whether you prefer SQL or streaming or whatever else. It wasn't our choice. So it was actually the people in the publishing company, they had already chosen most of these tools. They were already using DBT, so we just went with it because they wanted to continue using it. But yeah, it depends on the background that you have. So if you're coming from a SQL or a data analyst background, then you may prefer to use SQL. If you're coming from an engineering background, you may choose to use Python or some other programming language for doing the same kind of thing. But yeah, the concepts around data contracts still apply regardless of the programming languages that you choose or even the tools that you choose. All right, another alert that was fired in this case because the schema definition changed. So we had agreed with one of our sources that the last update date would never be null. And then suddenly we started to get null values. Luckily, we had tests for it, and then we caught that. And then we actually went and spoke with those producers, and then we were able to understand that, oh, someone had entered a test submission, which they had never done before. So then we were able to understand that, okay, if there is a test submission, these fields can be missing. And then we were able to go back to our validation, update our contract, and then like understand that, okay, if these fields are null, then it's probably a test submission. And then we mark those as test. So these kind of things you can catch early on, and it gives you a much quicker feedback than someone looking at a dashboard and then finding out that, okay, these numbers actually don't tally to what they should be. Business logic validation. So this is that example that Carmen was talking about where you received unexpected stages. And this kind of shows also some intelligence that we've built in. What has happened here is basically there was one alert that was fired around like July 19th. And that was because the pipeline had a gap. So the pipeline didn't run in time. And it detects the anomaly because it detects the pipeline run times each time. And these are like the data points that it received. But since there was a gap, you are now able to intelligently like alert on it. So there's some intelligence that you can add, but only if you have captured all your metrics and your test failures and volume changes and freshness changes over time. This was another example where we are alerting on the volume. So there was a data source which we were using where they would send us all the submissions that were in this new system. But the problem was suddenly it jumped almost doubled in the number of submissions that we got from this source. And then even they didn't know that their submission count had doubled. So since we were capturing the row count for that table before we started using their data, we were able to actually alert on it because there was a huge spike, and you can just add a simple standard deviation check to check it. And then we went back to them saying that, why have we received double the number of submissions? They were able to like basically go back to their dev team, debug, and they found out that they had introduced a bug in their system. So having monitoring actually helps you like identify issues that even people who are producing the data may not have identified in time. So definitely add like some sort of monitoring and like checks on volume and completeness and freshness and so on. And again, this will be very specific for your organization. So some people may really care about the accuracy of your data. So having tests around like the validation logic and making sure that your data is complete may be more relevant than like in some other cases where they don't really care about having all of your data, but they just want like the latest data. So depending on your use case, you may choose to focus on one aspect of monitoring over the other. The other thing that you may want to think about with monitoring is also understanding a bit more about how are your users using the data products that you've provided. So this is basically a dashboard that we created, which monitors our tables, which are the data products that you can see here. So there's a bunch of data products that we've provided to our users, and then we capture some trends around. So we capture some trends around like who are the people who are consuming our data, how many times have they queried our data, and also we obviously can't see who they are, but we capture like the different teams involved, the different users involved, so that we kind of have a better understanding of who are the people that are interested in our data products, so that we can then dive deeper as well. So there's deeper views into this that we haven't attached, but you can kind of understand what are the kind of queries they run and what are they doing with your data product. This will help you basically prioritize and understand a bit more about the mentality of your users, and also go talk to them about why are you using this in this way. You could like actually query this other table, which is simplified or something. So you can gather feedback from this kind of dashboard, and then like go talk to your users to improve your data products over time. And the other thing that you could do by having monitoring and alerting over time is evolve your data product to have some sort of service levels. And this may again depend on your business needs. But if you don't have monitoring, you cannot have any sort of service level agreements, or you may have, but you don't know if you're actually meeting them. So you can basically evolve your metrics that you've captured around freshness, completeness, quality into some sort of SLIs, which can be developed into like SLOs or SLAs, depending on your business needs. And if there are any regulatory or compliance requirements, then you'll have to think about that as well, of how do you actually, if you're like meeting those or not, based on your monitoring metrics. The other thing that I'll say, the only last point I'll say about this is, when you're thinking about your SLOs or SLAs, think about your data sources as well, because in a lot of cases you may not be in control of your data sources. So if they are not providing you reliable data, you are most likely not going to be able to provide or meet your SLOs. So think about your sources before you commit to any of your SLOs or SLAs. And yeah, with that, I'll leave you with the key takeaways. Yeah, that's it. Thank you. Any questions? No, silent. Okay. Thank you. Yeah. Oh, yeah. So yeah, finally, if you have any feedback for us, this is just our second event. Please fill this form out, and yeah, we'd be happy to hear what we can improve.